Okay? So this here, you would notice that this is a pairwise list plot of 2 at a time. This is the first one and the first one and the second one, first one and the third one. This is second one and the third one. So this is symmetric, right? So this is the same thing as that. Okay, except it is flipped, right? It's flipped. Sorry, it's flipped this way. You notice this part, this point here. Okay, let me make it a little bit bigger. This one looks like this one, but it's flipped. So this point here is this point here. This point here is this point here. Okay, and this is the first and the third. This value here is that one. It's kind of flipped. It's flipped along the 45-degree line. So this one is flipped. So this point here would appear here. This point here would appear here. Okay. Now the first and by itself, you plot the value with itself. It's just gonna be this straight line. So that's kind of not interesting. Okay. So that's it. So you have to put in this thing first. But because pairwise scatter plot is just a formatting, not part of the language, so you need to do this. So this you need to import. Okay. Now this is quite rare, by the way. Most of mathematical function is fundamental, so you don't have to do this import. Whereas with Python, the default is to import. Okay, that's why I forgot, because in Mathematica it's quite rare that you need to do import. Okay. Now,
excuse me, Professor. Can you go back to where you assign my 3D numerical data?
oh, where did I do that? Here.
3D one.
Okay. For those of you who have, say, 3 columns, okay, let's say you have 3 columns, 1, 3, and say 7. Okay, you can do that. But there were 3 of you who did, right? 3 of you only had 2 columns of numerical values. So we're just making it up. Just make a fake one, okay? So I'm just going to say that the third one is equal to this. Plus this. Okay, that's all.
Professor, if my data set, all of the columns in my data set are numerical data, do I have still to assign?
Yeah, you can choose any 3 then.
Okay.
Yeah.
So do I have to write assign each column to be like the numerical numbers?
You mean let's say you have 7 columns and they're all numerical?
Yes, something like that.
Oh, then that's even easier. In your case, you don't have to do this because you don't have to skip, you don't have to pick and choose any column, right? You stay at 4 columns. Okay, so if your data set already looks like this, Okay. Then all you need to do is type in 2 lines. Okay, and then you're done. Oops.
Thank you.
Sorry, I just hit it wrong. Yeah. Again, it's a matter of luck as to who has which data set, right? Anyway, I kind of screwed it up. Okay, so this is sort of like what you have to do now. You can do all this formatting in any other way. You can sort of like eliminate all this. It's not that interesting. Okay, so I'm not going to cover all that. So now you see that there are the 2 tools that you have. Pie chart, you pick that later. Sankey diagram is very useful, but I'm not covering that here. But the most basic, okay? In other words, you can't do anything, okay, in numerical data analysis if you don't know how to do these 2 things. The scatter plot, which is in Mathematica, it's called list plot, right? List plot. Okay. X1, Y1, X2, Y2, so on. Xn, Yn. Okay? So those are the 2 things that you need, okay, to do the very basic. Right? Today you've got just the very basic. Now, other things like heat map, network graph, Sankey diagram, these are all more interesting. But now I'm going to stop with the class assignment. Well, actually, there's one more class assignment. Okay? But I want you to go and look at this now. Okay? So, list plot, list line plot, blah, blah, blah. They're actually 3D list plot as well. Well, might as well do it. Okay. Now, this is not that interesting. You know why it's not that interesting? Anybody? Because X and Y, the third variable, the Z variable, the Z variable is just X plus Y. Let's make it more interesting. Let's make it yeah, I'm going to make a fake variable. Okay. Now this should be more interesting. It's not that interesting. So let's make it. See? Now, what it's doing, okay, what's this function here? it has the x1, that's the first column. Second column, oops. You remember this one, right? This is x1, this is x2, first column, second column. You still have that on top, see? But now you have the third value. Okay? So you get this kind of like jacket because it's random. I'm just making some function. Okay? It's making, so what it's giving you, it's not giving you something very nice. Okay? Now, if I see this in real life, I'm going to say this is random noise. And in fact, it is random noise. Okay? But in another case, it's going to give you some kind of pattern. So let's say I'm just going to make some pattern.
อาจารย์ครับ
ครับ
could you please slow down a little bit? It's extremely hard to keep track ครับ
Sorry. Okay. If you have 3 numerical data, okay, you can list plot them with this function, list plot 3b. Okay. Now, have you got to the point where you make 3 columns of numbers? Who haven't? All of you have got this thing. Okay. Have you got something like this to work with? So basically,
อาจารย์ครับ
ครับผม
I think some people don't have the data to be able to do so. I think if you can send us your data, we can follow more.
Okay, we can do that. I can do that. So let's do this. Let's do this. I'm going to just export it. Export. Okay, I'm just going to call it my sample data.csv. Okay. So, yeah. Okay. So let me give that to you guys. Okay, there. My intention was really for you to have different data set. I don't want you to have the same data set, but you know, if you really have a problem with having 3 numerical values, you can play with this. Okay? So again, what is it that we do here? One class exercise is you have 1 column, working with 1 dimensional data. Yeah. Class 2, working with 2-dimensional data set. Okay. Now do list plot, right? Okay. Okay. Number 3. Okay. Same here, exactly, same here. locate two data. Look now, in case we locate three columns with numerical values, assign it to 3-day data. Now, do list plot 3D. Okay. Note that in real life, you may have n greater than 2, right? Maybe greater than 3. Okay? And you want to see how each pair of attributes are related, you would just express.
Ajahn, can I see the code on how you make my 2D and 3D numerical data again?
Oh, tell you what, you have, do you have 2 or 3 numerical data set, that numerical column? How many?
I actually have 4.
You have 4, so that's easy, right? Okay, so let's say your data set, let's say this is the name of your data, right? Your data, right, has 4 columns, right? 4 columns. Okay, how many rows?
I'm not quite sure.
Okay, doesn't matter. Okay, has m row and 4 columns, right? To make one-dimensional data set, you just say, oops. Okay, you just do this. Your data, open bracket, right? And put in the columns, say 2, right? This will get you that, okay? Now, if, sorry, all and 2, right? Right? If your column has a heading, you might start from 2. You know how to do this, right? Now you can do that. Yeah? So next step. If you have 2 rows that are connected, sequence, right? You can do this to make one-dimensional data set. Okay? Now to make 2-dimensional data set. Okay. First you need this, right? Now, let's say the second column and the third column is what you want. Okay? Then all you have to do is this. Right? That's easy. Now, what if you don't want the second and the third? You want to skip. Okay? What if you want this? What if you want to do and fourth? Okay? That's why I have to say, let's create a new table. Then there's some other way of doing this, but I'm doing the tedious way. Table, okay, table, and you want what? The second and the fourth, right? Let's say you want the second and the fourth. Make it common. Okay, and you have to put that in a pair, right? And how many? You want to go I to the end of the data. What's the end of the data? Length of your data. Okay, that's it. Now, let's say you have, I want 3-dimensional data. Okay, you can do something like this, right? Your data 4 and say your data 7. Okay. Right? And you're done. Okay? What I did before was to make it up because there were 3 of you who only had 2 numerical. Right? 3 of you, I think, I don't know who it was, had only 2 numerical. So what I thought was, well, let's just make a third data by adding them. That's all. Okay? That's just an artificial case. Okay? We're just making up some fake data. Okay? Again, ideally, all of you would have, you know, at least 3 rows of that. The point is this. The point is this is what you can do. With one-dimensional data, you can do histogram. You can do this, right? With 2-dimensional, actually, you can do 2-dimensional histogram as well, okay? You can do list plot. You can also do histogram more than 1 dimension, right? Let me show you. Okay? So let me now do histogram 3D. Okay? And do. Okay, so this is, you know, this is what I want to do. That's it. There are only 3 class exercises. Okay, 3 class exercises. I would say that this is the beginning step. Okay. Histogram and scatter plot are this is it. And force scatter. Okay. So I want you to play with that and this thing. So that's it. That's your class assignment. Simple as that. Okay. Now, notice that we just covered these 2 things, A and B. Okay. In fact, there are more time series we haven't. Okay. So let's see if we can play with time series. For time series, I'm just gonna example. There's good time series here as well. Okay, let's do this. Let's do this. Let's try Dow Jones. Okay, you know how to do this, right? Query control equal, right? Dow Jones Industry. Okay, it's just going to search. Ah, good. Now, what can we do with that? Okay, what we can do with that? Entity type name. Okay, how do we get time series? Well, you would do this. You would go to financial data. By the way, if you notice, Mathematica put blockchain and cryptocurrency under the heading of financial data because you treat them in the same way. Okay, financial data. Okay, so for example, yeah, just look at some example. Oh, okay. Date list plot. Okay, so financial data, let's say it's the name of the company, and that is some kind of time series. This is a stock price or whatever. Okay, so this is an example that you can play with, but I'm skipping that for now because we won't be dealing with time series in this class. But you can do something like this. So financial time series, look up, blah, blah, blah. So yeah, this is good. So let's say I want to plot, and this is an example, this is not part of the, okay. Date list plot, financial time series data, let's say Apple, let's say Apple. And volume from 2010 to 2020. Okay. Now, the first time you enter this, it's going to take a little bit of time because it has to access the database. This is not just calculation. Okay. Date list plot. Okay, so it's for time series. In this case, you're referencing what's called financial data. Financial data comes in, various things like return, volume, volatility. In this case, it's just a volume from 2010 to 2020. Okay, so it's going to take a little bit of time because this is on the internet, and well, it's just going to show you something in a little bit. Okay, it's taking too long. Okay, but that will be over here. Okay, okay, so this is all the visualization on numerical data and maybe categorical data like boys and girls. But this is only a tiny bit, right? All this is before big data. All this is before big data. For big data, you want to do something else. And this is where my notebook comes in. Sorry, let me kill this. It's taking too long. Don't know why it takes too long. Okay. Now, this is where I want to show you how it's done. Data visualization. Yeah, and you have this. Now, I want to visualize not just data point, but I want to visualize location. Okay. For example, now let's do this. I want to look at Thailand. Yeah. I want to look at some country, let's say Thailand or Japan. The first thing I need to do is this. Okay. First thing is I want a country, right? I'm thinking about a country of Thailand. So I do Control Enter so that it searches. Okay, it found, okay, I want to do the country of Thailand. And let's say I want to do a country of Japan. Well, let's look at Thailand first, okay? And I'm going to say geo list plot the country of Thailand. Okay, notice two things. Number one, I'm not going to be plotting a data. I'm plotting a country. What does it mean? What does it mean depends on what function you call it. Thailand is a country, has so many data sets, the population, the geography, this and that. So this is like everything about Thailand, okay? But I want to do geo list plot. So that means that it's going to access the shape of the country. So it's going to do this, okay? Now the first time it runs a little bit, takes a while. So there's Thailand, okay? Now let's say I want another country. I just don't want just Thailand. I want control equal and say Japan. First, it's going to confirm, okay, that yes, you want the country of Japan. Oops. Sorry. Again, it's a list, right? Okay, so it shows Japan and Thailand. Okay. The point is that Thailand is a country, Japan is a country. The function determines what aspect of the data it's working with. And this is what I mean by higher level data now. Okay, so this is not like plotting Excel. This is something you cannot do in Excel. Okay, this is where you begin to have the V for variety. Remember that? Big data, volume, velocity, and variety. Now we have the first V, variety. Okay, so now I'm not plotting a population of Thailand. If I plot the population of Thailand, it's a number. This is not a number. This is actually a picture, a geographic description. So this is a top level. This is how data scientists deal in a very high level, abstractly, with the data. Okay. So I give another example, I guess. I think this is, again, I searched Chulalongkorn Mahavidyalai and Suvarnabhumi. So I say this is Chulalongkorn Mahavidyalai and this is Suvarnabhumi. Okay. You can do all kinds of stuff in here. You can find like the shortest path. Okay, all kind of functionality. But now we just visualize it. Okay. Now this visualization is a visualization of a whole bunch of things. These are examples that other people have worked out. This here, by the way, is like a list of country, right? To find the position, and it does this. Okay. Now, I'm not writing this from scratch, but I'll explain to you what it does. It says the country is the list of country data from the United Nations. Okay. Now, from each country, it looks up the capital. From each country, it looks up position of the capital. Right? Now, I use this specialized function, and this is the extension. Find the shortest tour. In other words, if you want to fly using an airplane to visit every single capital city, right? what is the shortest path given the position, and then draw that on the Earth. So this is the result. This just happened to be what's called the shortest tour. So these are all these little dots are different capital city. Okay, capital city of Thailand, capital city of Laos, capital city of Cambodia, Malaysia, Singapore, and this is all strung together to give a shortest path. What else can you do? Well, this is all kind of stuff. Well, this is giving I think this is giving the entities the distance from boundary or something. I don't know. I just made some example. So this is an example of visualization, but visualization of geographic information. Now, where would you find this? Okay. Now, those were just an example that I was interested in. But let's say language reference before. Okay. Visualization, geographic visualization. Okay. So all this will give you all that. Now, I don't know how many of you have geographic data. I don't think in the statistical you have, but you can see that you can do all kinds of stuff. GeoList plot is the most basic. That's the one that I show you, GeoList plot. Yeah. That's the most basic. Okay. In fact, this country, okay, it's from there. But you can do other things like geodensity plot. You can do contour plot. Okay, you can do contour plot. So, for example, this is a good. We can do this. Okay, let's take. I'm going to copy this. By the way, in the tutorial, if you click, it's just going to make a copy. So let's go to our little space. Okay. Oops. Sorry. Copy. Oh. For some reason, I keep having Thailand in here. Hold on. Ah, really weird. Hold on, guys. Wait a second. I don't know why. This has nothing to do with mathematics. It has something to do with my keyboard. Hold on. Well, this is not good. How about sorry, guys. Something stuck in my keyboard. It doesn't pick this up. It's got nothing to do with mathematics. Okay, so that's visualization, not just data now. It's geographic visualization. Okay. Finally, and this is the last exercise of today. Okay. What I want to do is working with interactive plots. Okay, interactive plot. Okay, let me show you what I mean. So let's go to, okay, one more thing. Let me show you one more thing before I go to interactive plot. You can also visualize events in terms of timeline. Okay. This is the time series things that I show you. Timeline. Okay. Let's say date object. Let's say today is today. Oh, you know what? I know what happened. Because I crashed the thing before. I didn't. Okay, now it should be okay. Okay. Date object. Okay, that's today. That's today, right? Now let's say I want to say the beginning of the year. Date object 2021 and January and 31st. Okay. Now between this and that is a date interval. From here, okay, to today. Oops. Okay. Now that is just a reference to an object called the date. Now I'm going to do timeline plot. Okay. So this is how I show timeline. This is how the visualization of timeline works. Let's say I have another one. I want to plot, say, another one from the COVID, let's say. So 2019. 12 to today. Okay, so this will be the timeline. Now the nice example that somebody worked out before is this. So I'm going to give you this worksheet. What this means is that instead of looking through the reference and find the function and start to create it from scratch, you can copy the template that somebody created. For example, in this case, if you go to this website, okay, this is sort of like a template somebody has built for you, like an example. And it's very nice. It has all the formatting, it has different colors and so forth. And you can start putting your own data. Now, obviously, this one uses different data, like romantic era, birth date of the composer. Obviously, you might want to do this for your family. So you substitute your own data inside here. Okay, inside here. So instead of having the list from the built-in example, like a romantic composer, you just put in your family. So this, your family, you know, somebody was born, somebody got married, whatever, you can do that. Okay, so this is all visualization. Okay, this is a time series visualization. So these are examples. Now I'm going to give you all of this to, you know, play with, but the best thing is to do both. Okay, go to this reference and you know, play with this time series and all that. This is all in here. This is all in here. Okay, there's a lot more. There's a lot more. Okay, social network graph, by the way, use graph visualization. So if you want to do like a Facebook tracking or something like that, you would look at the graph visualization. Okay, so now in class we saw example of visualize of geographical object, i.e. country map, as well as visualize of event timeline. Okay, so there's no class example here because it's a little bit more involved. Now, number 7. Okay, number 7. Okay, let's also visualize, say, i.e. plot a mathematical function. Okay. But let's introduce interactive mode. Okay, and this is a class exercise number 4. Okay, so let's think of some function. Okay, sine function if you want. Plot, right? And make it big. Sine function, sine of x. Okay, type this along with me because you're going to change this. Plot sine of x, x going from minus escape pi, comma. Okay, you should have this. Okay. Okay, everybody got that?
Professor ครับ How did you got pi ครับ
Escape pi. Okay. Now this is a shortcut. This is a shortcut. So okay, this is a shortcut. But if you didn't know any shortcut, you can do this. Go to palette, special character, go to symbol, and where's pi? Pi is here somewhere. Pi. Oops, not this pi. No, this is double pi. Okay. Pi. Okay. Yep. So everybody has this, right? This is very easy. Now, instead of plotting plot phi, okay, I want to add coefficient and phase shift. You know what the phase shift is, right? Ax plus b, right? So let's say I want to make it, so this now goes from -1 to +1, so I want to make it 2, right? Now, get this, right? This is the frequency multiplier. Now, I want it to be half as tall. Okay, but it's not that interesting because, you know, it just normalized. Okay, right? So the amplitude, let's say not that interesting. Now, this is the frequency plus phase. So let's say I add pi here. Okay. Now, notice, let me do this. Okay, you guys know from trigonometry, right? That sine of something plus pi over 2 is the same thing as cosine, right? Okay, so I can use this as a parameter. I can also use this as a parameter. Okay, let's go back. Let's go back. Oops. Okay, we have this, right? Now, what if I want to switch back and forth between sine and cosine? Okay, let's write down what I want to do. Want to switch back and forth between sine and cosine or other function. Okay, what else I want to do? Want to change the range of x. 3. Want to change the frequency and or phase, right? So right now the frequency is 2. This is the phase, correct? So let's see if I want to do this. Now, if I want to change this, I have to go and change it one at a time, right? So let's say this is 2, and now it's 3, and it's 4, right? It's quite tedious. So what I want to do is interactive mode. Interactive mode. Okay. What I do now is say, this is my frequency. Okay, I call this a frequency. Okay, frequency. And I set frequency from 1 to what? What do you want? 10? 5. Okay. And I want to manipulate. Okay. What it means is I want to manipulate what? I want to manipulate this guy in here. Okay. Yeah. This is a mathematical function. This is the range. This is the function plot. But I don't want to do it for just one. I want to make it interactive. So I set this as a frequency, as a parameter that I can manipulate. Okay. So what's the difference between frequency and x? X is something that ranges from minus pi to pi. But frequency is also over a range, but it's over a range that I, the interactive user, specify. Okay, so right now it's 1. Okay, so a nice style would be to say, I want to manipulate something. Just go to the second line. Okay, this is what I want to do. This is what I'm manipulating. Okay, I'm manipulating. See, this is frequency, right? And by the way, if you want to see the value, you can click this down. Right now it is 2.685. Can you animate this? Yes, you can. You can animate it. Okay, so this is like a little movie. This becomes the second most useful tools in Mathematica because now you can interactively play with whatever you want. Okay, so this is not a static visualization. This is now interactive visualization. Okay, and you can record this as a movie if you want to make an application. Sometimes when you make an, you want to have, let's say your project is to create some kind of data analytics tool, and you want to show that your app can perform calculation for different configuration. Okay, instead of just showing one configuration, you can just have this movie play different configuration. Okay, what else can I play with? Okay, let's start. Yeah, you can also make it fast. Okay, so that's not that interesting. So let's stop there. Okay, so now I play with frequency. How about I play with phase as well? Now, phase would only make sense what? Once you go to 0 to 2 pi, it comes back to the same thing. So you don't need that many. Right? Okay. So watch what happened when I play with phase. Okay. Now I'm going to have so many of them. So let me put, and this is formatting. This is not that interesting. Control placement to the right. Okay. So now I have phase, a frequency, and phase. Okay. So let's check the box. Change the rate. Oh, I haven't changed this. I have changed this. Okay, done. Okay, how about the range, right? Range phase. Well, instead of from pi minus pi to pi, I just go from A to B. Right? A to B. Where A, let's say, what do you want? From minus pi to okay, to minus 10 pi. Okay, and B from, let's say, plus pi to plus 10 pi. I'm just making this up. Okay, so now if I move A out, it goes deeper to the back. Right? If I move B, okay, so there, I'm done.
อาจารย์ครับ may I ask something when we run and this square bracket here change into the both square bracket and it keep running and never stop, how can we stop it?
What doesn't stop? You mean,
yes,
well, if the program hands, you can do this. You go to evaluation and do abort.
abort. Okay.
That's like pull the plug. Okay.
Okay. Thank you.
So now we can control 4 things. Sorry. 1, 2, 3. You can do this, right? What about you want to switch back between sine and cosine? Now this is nice because even this, okay, is a parameter. You can say, I don't want to plot sine. I want to plot some function. Okay, and that function, now function is not numerical, right? So you can't give it something like 1 and 2. It doesn't make sense. It doesn't make sense. You have to give it a list of functions. So you have to give it a list of functions, sine, cosine, and maybe exponential. Or, yeah, logarithm. Okay, so now you can do this. Okay, so this is an interactive thing. So imagine this is, okay, so try this. Okay, now, obviously, you don't have to use the same function. Okay, you can do something like, well, and this is the last topic for today. Okay, this is the last topic today. Let's say, okay, let's say you want to have your own function. My funny function. Okay, x is equal to x squared minus 5x to the 0.5. I don't know. Yeah, I just want to do something funny. I don't know what it means. Right? Now, notice what happened. I have to name the function first. Okay, I have to name the function first. Okay, I have to name the function first. If I don't want to name the function, but I want to use it, how would I do that? And this is what we mean by pure function. Okay, copy this formula, put it here. Put it there. Instead of x, you put in the hash sign to say, put it here. This is where you put the variable. Okay? And you add what's called an ampersand sign. This is a notation to say that it's a pure function. Where's my ampersand? Okay? And I can do this. This is called a pure function. This is a pure function. Okay. If I did this and then I apply to x, sorry. Okay. It substitute x in here. So it's minus 5x to this, right? So if I did this, yeah, that's my formula. But I don't want to apply to just x, so I make it apply to hash sign, and I call this a function. This is a pure function. Okay? It's a little bit tricky to understand. Now, if I don't want to use x, I want to use, say, y instead. T. I get the same thing. So this is what's called a pure function, substituting t in the placeholder. Now this thing, by the way, I'm not going to hold you to it because it's a little bit advanced. Okay, but for those of you who are going to be specializing in the applied digital track, applied digital intelligence track, a lot of your programming will be simplified if you use pure function. So I just want to show you right now, okay? But it's not a crucial part of this class. Okay. So you can see that now it has parameter to play with. Now, obviously, you can play a whole bunch of them, but it's kind of like it's not going to make that much sense. Okay. So what this function does, okay, this is the real function you're interested in. This is the real function you're interested in. These are the parameters. Instead of changing the parameter and redo the function, you put the parameter as if it is a variable and you can control it. Okay? This is all you want to do. This is what you want to do. But you want to do it once for function is sine, once for cosine, once for log, for frequency from 1 to 5, phase from 0 to 2 pi, a from minus pi to minus 10 pi, b from plus pi to plus 10 pi. Okay, so all the parameters become variable, but it's not the function variable, it's a variable that you use your hand to variable. Okay, that's why it's called manipulate. Okay, manipulate comes from the word hand. Okay? By hand, manipulate. Okay, so manipulate by hand. So that's why you have this. Okay? This is interactive mode. So now, okay, now what I want you to do is plot okay, create a plot function of your own using manipulate. Okay. For example, you can do this. You can say something like manipulate. Okay. Plot a x to the power b. Okay, power b. Okay, x from 0 to 10, and I want to manipulate a from 1 to 5 to 3, and b from 3 to 7. I don't care. Okay. Something like that. Okay. Come up with your own function here. Now, this one you don't have to put pure function because you just put in x, you substitute x. The reason we had to do the pure function over here is because you're calling a function. Okay, that's a little bit of starting point. So this is your last example, exercise number 4. Okay. And that's it. That's pretty much all I want to do. Now, what happens now? Yeah, what happens now? Let's go to the syllabus. This one here, statistical description, I will cover it as part of this. Okay. Okay. So this is a review. This is a review. Next week is a review. Review probability statistic that you would need. Review linear algebra that you would need. Linear calculus. So now what happened? We have the understanding of what data science is all about. You have the primitive tools in Mathematica, right? How to program in a very high level. You understand data visualization. Okay. Starting in exercise 1, 2, 3, 4 with numerical. Okay? And then I show you whole other visualization that you're not yet responsible for. Not yet. Okay. Now note that non-numerical data, i.e. the variety P in big data, okay, e.g. Okay. Note that in your project, okay, you might want to work exclusively with non-numerical data. Okay. In which case there are other visualization tools not shown today. e.g. show graph or social network. Okay. Social network. Okay. So what else you want to do? Molecular data. Okay, that's for today. So today, to make life simple, okay. Whereas last class, in the last class, you used sample data to get some example, to get to the data set. In your project, you might want to import your data from elsewhere and export your result in various formats. Hence, yeah. So today is visualization, but this is not visualization. This is importing data, working with data. Visualization, when you use it in the beginning, in the middle, in the end, you use it every time, everywhere. Okay. The first thing I want to introduce, okay, let's start with numerical data. Okay. So working with one-dimensional numerical data set, okay, take your data set from last class, okay, look for column and do this. Okay, so you can do histogram, you can do list plot. So if you get these two tools, histogram and list plot, 2-dimension, 3-dimension. Okay. This is my comment. Comment. There's your comment. Okay. So finally, my comment is manipulate is the go-to tool for prototyping your app. Yeah, I'm gonna put it like this. For prototyping app. ID demonstration to clients. Okay. As a matter of fact, your final project, doesn't matter what you do, the presentation of your final project most likely will involve some kind of manipulation. Okay. The idea is to turn parameter into something that into quantity that the user can change manually. Okay, that's the idea. Right? So what's the idea here? The idea here is you have a function. That function has parameter, but that parameter is not up to you. It's up to the user. So I want to use this application to draw sine wave, but I want to specify different frequency. How will I do that? Well, we turn the frequency into the parameter that can be changed, and now I can do this. Okay, and I can demonstrate. Okay, and this is why, in fact, this is probably a third of the reason why I'm using Mathematica to teach this class. Because most of you who are not going to the digital, applied digital intelligence track might want to prototype application, communicate idea, show the design of the project, but allowing the user to interact. And this manipulating tool is very powerful, okay? And to do this in Python, it would take forever. It would take forever, okay? So this is why this is extremely useful, extremely powerful. Okay, so this is side note for today. Okay, I've got the date, right? Let me save that. So I would like you to turn in your class exercise, I guess, by 5 o'clock, because I really literally I want this to be class exercise. I don't want it to be homework. Okay.
อาจารย์ครับ many of our students cannot follow the class today. They may have to revise it again and might take time.
How about this? Now, do we okay? Make the portal for 5 o'clock today. Okay, and make another one for tomorrow. 8 a.m.
Uh-huh.
8 p.m. Okay, tomorrow evening. Okay. And-
Evening. Okay.
Yeah, so whoever can submit to the 5 o'clock, do that. If you can't, go to the next round. And maybe the 5 o'clock, if it's done well, can get more points, I don't know. Something like that, okay? So make 2 submission round, 5 o'clock and 8 p.m. tomorrow.
Okay.
Okay, good.
Ajan, I have a question.
Where are you? Yep.
Like if I have only 2 columns, how do I do the 3D number data?
That's what I was showing earlier. When you take just make the 2 column and just add the 3rd column.
I use I type in the code that you did and it doesn't work.
Okay. You mean this step, right? This step when you say take something like my data, and column 2, say, right? And this is one of them, right? And this is another one, correct? Now you can do this, right? This, comma, this, right? We have 2 columns already, right? The 3rd column, you just copy it and just put it here, comma, and just make addition or something. Okay, I'm not looking for realistic or meaningful thing. I just want you to exercise this. This is a pure exercise thing. Okay, so you can see that it's a bracket, right? It's a bracket. First one, second one. Okay, let's do this. Okay, and now you have the 3rd one, comma. How long? I length of my data. Make this table. Okay, does this help? If I write in one line, it looks a little bit hard. Okay, so I take some column, I take another column, and then I add them. Okay, there are more clever way of doing this kind of thing, but I just want to keep it like this one. Okay, so the length of the data is going to say everything, right? And that's my new table. So my 3D numerical data is equal to this. Does that help? Hello, Ka, where are you? Does that help?
Yes, ka.
Okay, Ka. Now, again, you can put anything in here. So this I'm not, saving because it's not that important. Now you have this one, right? Visualization. You have this, right? Machine learning, data analytics, visualization. I think you have it, yeah. Should be in course view anyway. Okay. So, there are other things that will come back later. In fact, once you got this this tool, scatter plot, histogram, that takes care of most of the numerical visualization in the beginning. Okay, and then you have a whole bunch of other charts and plot. So anything that can be done and more with spreadsheet, you can do it here. So now what happened is next week we're going to start to try to go to here, right? But we can't do it Let me show you. Okay, this is the whole game plan. Okay, the whole game plan is this. Okay, doing data analytics with statistical method and machine learning. That's the whole game. But the statistical method, you have done some of that already, most of it already. So it's going to be the review. So I'm going to review statistical method, not teach it. I'm going to also review linear algebra and calculus because those two are needed here. Okay, so next week is review. Okay, let's review. Okay, so with that, I think how are we doing on time? Oh, okay, we run out of time. But stay on and ask me questions. Again, the tools today, it's just very simple visualization. It's a lot of it is almost a repeat of what you did in Excel, except in Excel, you can't do it with real big data. You can really do it with something you can highlight, right? But you can do more, okay? But the example, the homework, the example here, class exercise 1, 2, and 3. In theory, you can do all this with Excel. Okay? You can't do it from number 6 on. You can't do this now. Okay? You can't visualize timeline. You can't visualize country map. You can't do interactivity. Okay? Okay.
อาจารย์คะ
ครับ
so I want to inform you that can we have more time than like one day because I think Mathematica can be understandable if we have some time to learn or
Okay.
study.
How about we make 5 o'clock today and then 8 p.m. on Thursday? Does that help?
Thursday?
Yeah.
Okay. Thank you ค่ะ
Or you want Friday?
Yeah, it will be nice.
Who wants
Okay,
Friday?
we want
Raise your
Friday.
hand. And nobody wants Friday. Oh, wait. Now you.
Oh, I want Friday.
Fine. I get it. Calm down. Sorry. Again, my apology, and I apologize ahead of time for going quickly. And you guys are doing a good job of keeping me to slow down. Okay, that's fine. But the material is not all that difficult. Okay, the material is not that difficult. It's just take some getting used to because you're not used to communicating with a computer by instruction that uses function. So it's a different way of speaking. Okay, it's a new language. But that is the kind of language. It doesn't matter if you speak Python or Dev or Java. Chances are, unless you're a professional programmer, you would have to communicate with it through this kind of function. Okay, so 5 o'clock for one lot, and then Friday 8 o'clock. Now, if you submit 5 o'clock and you think you can do a better job by Friday, you can resubmit on Friday. Okay, but if you get a decent job by 5 o'clock, then that means pretty good. Okay, though. Again, next week is review. So instead of telling you what else I'm going to teach on Tuesday, you should be looking back at your class note from last year and from high school. Okay, if you learn high school in calculus in high school, take those notes. If you learn calculus from last year, take those notes. That's going to be next Tuesday. Okay, and that for the part that has to do with statistics, I'm going to also show you the plot, statistical plot. Okay, so that has a little bit of mathematics as well. Okay, though. Okay, guys. You're doing well if you're sticking to this, because again, I know I speak fast. Okay. Anything else?
Can I
อาจารย์ครับ you can go first
okay.
Yeah, anyone.
I'm still confused. How can I define what I imported to a variable? Do I have to define what I imported to a variable before I plot it?
Yes. Well, the way it looks like is like this, right? So let me bring this up quickly. Okay, you can say my data. Okay, my data is equal to import.
Oh, so I see. Okay, thank you.
Right?
Yes.
And then you can plot. Okay. But certainly, if you don't want to name this, you can just put this over here.
Oh.
Yeah, you can do that as well. Okay. The difference is that if you do this and you want to get to the value again, you can imagine that the file is huge. So it takes you 2 minutes to import, right? If you did this and you want it again, you have to re-import. So that's not a good idea. So you have to name it first, so that next time you don't have to re-import. It's like assigning memory, and that's all.
Okay.
Yeah, but the problem we have here is so tiny data. It takes microseconds to import. So that's not the issue. Okay, Tom? Okay, another guy. I got another question.
so can you send us the file that you used to teach in this class?
Yes, of course. I think you mean the side note? Yeah, I'll put that in line right now.
Yeah.
Yeah. The mathematical file, I think, should be in the course view already, but I can put it here. Okay. It's quite small.
Please include the notebook that you just created today.
Okay,ครับ we'll do. ไม่ได้อยู่ในคอร์สวิวนะพี่นึกว่าอยู่ในคอร์สวิวโอเคจ้ะ
Also, like in the next class, can you also like type slower?
Okay.
Because I can understand you, and like I can cope with your speaking speed, but not your typing speed.
Okay, we'll do.
Yeah.
Okay,
thank you.
So let me do that right away. So I go to the side note for today, class 3, and visualization and side note. Okay. Okay. So I'll see you on Tuesday. Oh, sorry. One more.
We only have to do for one data set, right? Like for one. We only have to do for one data set, right?
Do it from your data set, yeah. So everybody will be different.
Only one of them, or do we have to do both?
Well, it depends on how diligent you are. If you want to impress me, you can do more than one. By the way, all the class exercise are just that, class exercise. If you do more and you want to show it, yeah, certainly. That's what separates the A student from B student, right? B student that's what's required. A student does a little bit more. Yeah, so certainly you need to do one data set at least, but to do more than one, that's even better. Okay. You can even use the name of the file as the parameter in the manipulator. So you can have one manipulator that say, okay, plot data set 1 versus plot data set 2. You can do that as well. Okay. So you have the access, same access as I do to the mathematical manual and the resource. So you can add any kind of fancy features to it as you please. Okay. So submit the best student, the really good student. You would really impress me if you submit something to me by 5 o'clock, well, which is half an hour. Let's make it 5:30. 5:30, and then on Friday submit something really fancy. เอา5 โมงครึ่งกันนะพูดนานไหม นะ5 โมงครึ่งกับ2 ทุ่มวันศุกร์
ครับ
โอเคครับ Okay, remember to go back to your textbook on statistics, linear algebra, and calculus. I can't teach all that in 3 hours. I can only review and highlight things that you need for data analytics. Okay,ครับ Any more questions? Okay. Okay,ครับ. So I'll see you on Tuesday. Okay, and I'll try to work out something with the microphone. By the way, you can hear me okay, right? I mean, it's a little bit echoey, but okay,ครับ. Okay, bye bye. I'll see you when I see you. Stop share and okay, ครับ สวัสดีครับ
Thank you ครับสวัสดีครับ
สวัสดีครับ สวัสดีครับ
ขอบคุณ
Thank you ค่ะ
Thank you
บ๊ายบายจ้ะ
Thank you ค่ะ
โชคดีค่ะโชคดีลูก
Thank you ค่ะ
Thank you